teachers, school leaders, and math enthusiasts. Thank you all for joining us on this very special occasion of National Mathematics Day. We welcome you to this special masterclass of Decoding the Magic of Mathematics. With us, we have an expert educator who would be sharing insights on how you can convert your maths class into fun. It gives me immense pleasure to introduce to all of you Mr. Satyam Mishra, a UNESCO Global Teacher finalist, 3-time TEDx speaker, and a renowned global educator. For his work with the marginalized communities, Mr. Satyam Mishra has also been elected as a Shaper and Impact Officer at the Global Shapers Community, an initiative of the World Economic Forum. Not just this, he has also taught students across geographies like South Africa, Nepal, Austria, Bulgaria and Lebanon. And in fact, he was also the very first Indian to be invited to teach at the Malala Yousafzai All-Girls School. Satyam believes teachers are the shapers of education and has devoted his life towards transforming classrooms and the way students look at the world. So without further ado, ladies and gentlemen, let me present to you Mr. Satyam Mishra.
Thank you so much for that introduction. I'm very pleased to be here. I love the work that Teachmint is doing, and I think the way it has been inspiring teachers, helping teachers across India. I congratulate the team, and I hope that you're able to magnify, multiply your impact several times over in the coming years. I just want to tell you that, when I was 7 years old, I was in grade 2, I remember, and my grandmother was 72 at that point. I was very, very attached to her. I was the youngest in the family. She was the oldest. And I loved listening stories from her and, the general grandson-grandmother bond that we share. When I was in grade 2, I discovered that my grandmother had to depend on me if she had to read something, say a card or a newspaper or anything. She would ask me to read. I did not find anything problematic there, but I would think, why does she have to depend on anyone for that matter? I would love to read things to her all my life, but then she doesn't need to be dependent on anyone. Was my thought. My granny and I started working, as very cool friends, and in a year she was literate. She could read on her own in 1 year's time. By the time I was writing my grade 3 quarterly exam, she was already illiterate. She could read and understand what she was reading in Hindi. And that made me so confident. That taught me two things as a teacher. Point number one, that there's no age to learning. You can learn whenever you choose to learn. And second, that, I generally started to believe, you can call me foolish, but I generally started to believe that I had the power or the magic to get people out of illiteracy. I had learned something where I can help people become independent in a lot of ways. My grandmother is 96 years old today, and she doesn't need my help, which makes me so proud. Every time I see her read newspapers, I just feel that, it is my contribution, and I feel so happy. It is our contribution technically, because she was the one to let me help her with literacy. That started my love with teaching, and anything that I would learn or anything that I would work on, I would have some part of my brain constantly thinking, how do I explain it to a student from the junior classes, or to someone elder? How can I have a conversation with someone elder around, say, certain topics? For example, the photoelectric effect, or periodic table, or sequence and series, calculus. So my idea was that, okay, say I'm in grade 11th, how can I discuss it with someone who's already studying engineering? And at the same time, how can I explain this topic to someone who's still in grade 7th? And that kind of helped me come up with n number of ways to solve any question. It just made me I was very curious from the very beginning, and I was always good with numbers. So those are the two things that helped me truly fall in love with learning and truly fall in love with teaching. And that is one reason why I am very proudly interacting with all you wonderful teachers out there through this amazing platform that Teachmint has created for me. I'm very, very grateful. And today I'm going to be discussing a number of steps and strategies with you that probably is going to help you in your classrooms. And we together are going to change the way education is looked at in our country, making sure that we prepare our children for the challenges that lay ahead in the future. Debating mathematics, that concept might seem very odd to a lot of teachers, but it should not technically. We debate or we relate debates to certain subjects only. For example, we relate debates to history, to our English classes or to our Hindi classes. But we never usually relate debate to mathematics. Whereas mathematics is one subject that has been entirely based on logic and debate. So it is not who has age or experience or degrees on their side. It is the one with the best logic who wins in a math quiz or in a math debate. So I devised this method by the name of Spark. Now, when do you conduct Spark? You conduct Spark only after you have finished a chapter. So once you have finished the chapter, the students have a great command over the basics of the chapter. Only then you go for this at the say you have taken 3 days to conclude a chapter. Spark will happen only on the fourth day when the students have complete idea about what's going on. Say debating math, so you have got, now I'll give you a quick example of a chapter by the name of mean median mode. We have this chapter. The interesting part about this chapter is that this is present from, I think, grade 5th onwards. Every year or every 2 years this concept is repeated. You ask any good student, I mean anyone who loves math, anyone who claims that he or she understands most of the concepts. You ask any student in your classroom, they will probably tell you the definition. They will probably be able to calculate and tell you what the mean and the median or the mode of the data is. And they would also be very clear about how to calculate it. But if you ask even the top 5% of your class across schools, that why do we need mean and median? I mean, what different data do we get? What different data points do we get if we calculate the mean of a given set of data and the median of a given set of data? I'm quite sure that 99% of the students will not be able to answer you what is the basic difference. And that is a flaw of our system which we need to rectify. So quickly talking about, say, I'll give you a quick situation. So for example, there is a class X, and in class X you've got, let's name it X1. Now you've got class X1 and you've got 10 students in that class. One student gets a $10 million job offer and the other 9 do not have a job. If you calculate the mean of this data, you will have the answer as $1 million. So that gives you a rough impression that everyone in the class got $1 million offer, which is not the case. Whereas if you find the median of this data, it's going to be a 0. That's what I want you to reflect on. This is your technical Spark question with your students, discussing and then posing them a real life question. For example, that we are dealing with mean, median and mode. Great. If you're looking at a B school, that you're going to apply for, what are you likely to get more information from regarding your salary, the mean of the data or the median of the data? The second question is, so these are the debate questions. How is mean of a data different from median of a data in a real world? In a world which they understand the use of why this is method A and this is method B, and not all of it put together or just the definition or formula of this. We also understand that suppose there is a big difference between mean and median. What does it talk about data? What does it say about data? Is it a regular flowing data? Is it a data that has high margins? So I think that is one area where we can work on debating the concepts of math towards the end of classes, as we conclude the class, and the teacher serves as the moderator for this debate. We don't have technically groups A and groups B, but then we have created a class culture where we can sit and discuss concepts that are going to change the way students think, get them to the very basic depths of mathematics so that they can apply it to real world, as well as they have a much clear understanding of what's going around. Well, if you ask a regular normal student what is he or she most scared of about math or science for that matter, they're going to name formulas as the first problem or first scare that they come across when they are working with math or science. We have unfortunately created a space where the students are convinced that mathematics is one subject which is loaded with formulas. You have to memorize them. It is very abstract. Now, that's the irony. Mathematics, which is a subject that's based completely on logic, completely on real life, is considered to be abstract by a lot of students. And I think that needs to go. And one of the prime focuses, one of the major focus areas that we have in getting rid of this misconception is mathematics without formulas. So mathematics without formulas, right? What does that mean? Well, we clearly know that formulas are essentially based on math, not the other way around. Mathematics is not based on formulas, whereas formulas are based on math. For example, we know that a plus b whole squared, we know that it's a squared plus b squared plus 2ab. Ask any student, that okay, a square understood, b square understood. What about this? Where does this come from? A lot of students will not be able to tell you where does that 2ab come from and how does it happen. Well, one of the primary techniques that they will use is, which is a good one, is they will expand it. They will go for the binomial distribution of this and figure out the result. That's one of the ways they prove it, and it's right. But how can you make it all the more appealing and visual so that no one in your class... Now, let me tell you this. When you are dealing with your classroom, you're not dealing with the top 5% or the top 10% or the bottom 5% or the bottom 10% only. You are dealing with every single student present in your class. And these methods are aimed at helping every single child in your class. So a square plus b square, let's take a square with dimensions as a plus b. That's a square, right? What is the area going to be? So area of the square is going to be a plus b whole squared. I think that's true. Now, we take a and b as arbitrary points here. So this is a, b, this is a, b, this is a, b, this is a, b. Done. Now we just align this. We have the sides as a plus b, as you can see on all four sides. So the area of the square is a plus b whole square. Now just look at this. Don't you think this is a square of area a square? This is a square of area that's b square. This is a rectangle AB and this is another rectangle AB. So when you add it, the area of the square becomes a square plus b square plus 2ab. That's the figurative explanation of what we have been learning in a very abstract way in most of our classrooms. So this changes a lot in terms of instructions and in terms of the way students receive information. The last thing that I would talk about in this is, well, we are experts at teaching quadratic equations. We get into our classrooms and we say, okay, quadratic equation is of this form where A is not equal to 0. That's the traditional way of going about it, right? That's what we do. Now, we never really challenge students one more step. That's math without formulas. That's how you ask them to challenge. That's how you use mathematics to awaken their logical and reasoning abilities. Now, what if A were to be 0? If that would have been the case, this would have become 0. Had A been 0, this would have become 0, and the degree of the equation would have become 1. So rather than being a quadratic equation, this would have become a linear equation. Now that's the whole point. All you did was introduce just this what if, challenging what the regular textbook teaches you every single time, and we as teachers go and write it. We make sure that the students write it in their notebooks and understand that, okay, the standard equation is ax squared plus bx plus c is equal to 0, where a is not equal to 0. But I think we miss the point, and that's what happens with over 50 to 60% of the class, that they don't really know what if a happens to be 0. How would it change the equation? And once you discuss this with your students, they also get to understand the difference between linear equation, quadratic equation. They understand much better now about the degree of the equation. They understand very well that how degree of an equation influences the number of solutions that an equation can have. All of that just by going a step further and asking the class, what if A is equal to 0? As simple as that. And we have a range of topics to learn, to share, and to understand math in terms of degree, in terms of equations, in terms of simultaneous linear equations, general linear equation, quadratic equation, and then probably a cubic equation as well, if that's the demand of the class. So this is our idea of math without formulas, where we are inspiring our children to not be scared of the subject because of formulas, but to be able to derive those formulas so that they become great mathematicians. They understand the beauty of it, they understand how it works, and they are able to even reflect on the details of mathematics, which a lot of children today miss out on. My next topic is connecting topics. What do I actually mean by that? So, for example, let's consider three topics. Let's consider percentage, fractions, and decimals. Now, these are taught in grade fourth, fifth onwards. So there's percentage, there's fractions, there's decimals. Now, even if a student is understanding these concepts separately, it takes them a while to connect these three chapters together, or these three concepts together. Let's get a sense of it. For example, probability is completely based on fractions. That too, proper fractions. A quick representation or number lines. Now, what if I'm just giving you one of the literally hundreds of examples that we can connect based on the requirement of our classroom, based on what the students need the most. So this takes a while for the students to connect. They're not able to technically understand that this actually represents the same numbers, or they can potentially represent the same numbers. Now, if I just give you a quick example of 75%, and I put a dash here, the students are quick to understand that fraction would be 3 by 4, decimal would be 0.75, and on the number line, this would somewhat be here. Rough idea of where it would lie on a number line. Suppose I give you 5 by 4, and I ask you the other details. 5 by 4 clearly means 125%, because this is greater than 1. It's an improper fraction. And then decimal wise, it would be 1.25. And then on a number line, it has to be between 1 and 2, somewhere here, close to 1 rather than close to 2. Now, just this simple exercise can actually help students connect these topics, work very, very well with these numbers. And the moment you say 60%, the student is able to quickly visualize that 60% is 3 by 5, 60% is 0.6. I mean, they don't even have to work very hard on understanding the basics of it, the hidden information that's there, whether the number is proper or improper. How do you go about it? How do you represent it in terms of percentage, or in terms of decimal, or in terms of fractions? Connecting topics is a very powerful link. For example, I'll just leave you with one more question, dear teachers. How do you connect something like a 2D and a 3D? Can you connect 2D and 3D shapes and change the way all students visualize mensuration in your classroom? For example, can they understand that a rectangle is a 2D shape, with a height is actually a cuboid? Can they actually visualize that a square, which is a 2D shape, given a height equal to the length and breadth of that square, which means length equal to breadth equal to height, will actually be a cube in 3D shapes? Can they visualize that a circle with a height will give them a cylinder? So simple things, how a pyramid is formed, how different shapes are formed, and why is area measured in unit square? Surface area will always be measured in unit square, whereas volume is always measured in unit cube. Once they have figured this out, all these doubts will disappear on its own, because the students are now thinking at a very different level. They are not just looking at exercises or formulas or content in their books. They are looking at mathematics in a way and form that it should be looked at. So let's explore the hidden connections between these chapters, and let's go beyond books to help students explore what is best for them and empower them with a vision where they can connect topics across subjects, they can connect subjects together even greater, and become masters of the game. What I'm going to be talking about is a very different approach to looking at math and science. Well, if you ask a teenager, a youngster on the streets of India or anywhere in the world, who their favorite icons are, they're likely to name a football player, an athlete, a politician, a model, or a Hollywood or a Bollywood star. You will hardly come across even one teenager who would say that a scientist is his hero or her hero. That is very rare, and I think we are primarily to be blamed for that, for a number of reasons. But one of the reasons is that scientists, usually in our books, are somewhere placed in the corner, and are used more for doodles by the students. They make crazy faces out of those poor scientists in the books, and not enough attention is paid to the scientists. Now, one concept that can actually change that is celebrating scientists. For example, I'll just give you a quick example. We were learning about the sum of n natural numbers, right? The sum of n natural numbers. I was working with a group of grade 9 students, and I gave them a task. The task was that you have to add numbers from 1 to 100 and tell me the answer. You can, of course, you cannot use calculators. You are not supposed to be using any formulas, and they were not even aware of a formula by then. So you have to add these numbers and let me know. And you can be as creative in your methods as possible. That was the basic instruction. Be as creative as possible with your method. I'm not going to question that, but let me get the answer to this question. What is 1 plus 2 plus 3 plus 4 plus all the way till 100? Give me the answer. And you won't believe I left them that way for about 6-7 minutes, and they kept adding and they kept adding, and they figured out that it was one very tough and boring exercise. Now comes Gauze in the picture, whose story was right there in the book, but then not many people had paid attention to it. It's a disputed story. Some people say it's true, some people say it's not true. But I think to kind of get young kids motivated about learning and celebrating science and scientists, I think it's a great way to proceed. I told them exactly what the story said, that, an 8-year-old Gauze was punished by his teacher for being too talkative in the class back in 1784 probably, and he was asked to add numbers from 1 to 100, the same task that my students were busy with for the last 6 or 7 minutes. What did this person, this child, 8-year-old child, technically in grade 3 in today's curriculum and age factor, Gauze said that, okay, let me add these numbers, so 1 plus 2 plus all the way till 100. Let me reverse it and add, so this becomes 100 plus 99 plus all the way till 1. Now you know that 1 plus 2 plus 3 is 6, and so is 3 plus 2 plus 1. So you add the numbers from left to right or from right to left, you get the same answer, right? So the sum essentially is the same if you write it from 1 to 100 or from 100 to 1, the same. Now once you add it, you get 2 times the sum of numbers, and then you get all of this as 101, all of this. So you have 101 plus 101 all the way for 100 times, which means twice sum is equal to 100 times. So therefore the sum of numbers, natural numbers, 100 is 101 into 100 divided by 2. The formula being n into n plus 1 by 2. Now just imagine, what did we actually learn in the last 3 minutes or so? We are discussing about a genius Gauze. And why are we doing that? We are doing that to help children understand and respect the brilliance of this scientist. We are trying to help them understand why are scientists that gifted, and how can they be one of the scientists in the coming years, if they continue to work very, very hard and with a lot of passion. We are getting them to discover about these incredible people and respect their brilliance. Also understanding that, which bright mind was working on these solutions, on these formulas, and what did they achieve in a very short span of time. Solving a problem, a world problem that is helping all of us even today. So celebrating scientists, celebrating the work of Archimedes, celebrating the work of Gauze, celebrating and getting into their shoes. I discovered that a lot of students were able to relate better once I took 2 to 3 minutes to just take them to that era. We called it the time machine. Where we would take those students, where we would be like, okay, you were in 1784. What do you visualize around you? You have nothing, you have no gadgets, you have nothing, right? And you're working on this problem. How electricity would have been invented, how an electric bulb would have been invented. Stories to inspire young minds, because once they get inspired, they're bound to start creating sooner or later. So I strongly believe that we are creating the scientists of the future right in our classrooms. We need to be celebrating scientists to help them understand how cool their work has been and how important it has been to shape our math and science today. With that having said, how do you give them interest and a platform to start exploring that, okay, this was great, can I try something new on my own and derive or come up with a pattern or a sequence that can help other students or that can help the coming generations. If the child is a genius, or if we are able to tap into that genius within him or her. In my teaching career, I have been very fortunate to have worked with students with special needs. Uh, Students with special needs can be defined under a very broad range, but the students that I was catering to as a teacher uh, had been diagnosed with learning disabilities, for example, dyslexia, dysgraphia, dyscalculia. That made them struggle with very basic subjects, and their struggle was very real. And as a teacher, I was very convinced that there are methods to help them evolve, grow, and reach their true and full potential. I would be discussing a couple of steps that helped children with special needs thrive and excel. For example, one of my students, just following these methods, just giving you a concrete example, he had scored 1 out of 40 on a unit test when we had started working. I think we had just had a week to work. We would conduct exams every 6 weeks. So in the next unit test, the same person scored 32 out of 40. And he continued kind of scoring on similar 80%, 75 to 85% average. So my simple idea is that if you innovate, you learn and grow as a teacher, and I think that is incredible and essential to helping every single child in your classroom. I'm going to be discussing 3 ideas with you based on retention, based on how do you actually use this opportunity to create something new for students with special needs. Now, it's not just specific to students with special needs. Anyone in your regular class who's struggling can absolutely benefit from the same methods, because either retention is a problem, or the kid is not able to understand what you're trying to tell him or her, or there is a problem in understanding the concept, or the kid is already very scared of the topic based on the information he has probably received from his seniors, based on the fact that he has failed a couple of times trying to master that concept, so that fear has got on to him or her. So I think these methods are going to be absolutely path breaking for all these children with special needs, children who are doing very well in your classroom but who are struggling in certain areas, certain concepts. If you're working with women resuming studies, or if you're working with adults in general who are resuming studies, who want to come back to the education system, say after a break of 10 years or 5 years or 7 years, I think these are helpful for this entire lot. So have a look at the 3 methods that I'm going to discuss with you. Do let me know your thoughts, and can you create something which can absolutely help students who are struggling in your classrooms given certain concepts. What I'm going to talk about is very close to my heart, and something that I have learned. I have learned the most teaching children with special needs, and I think most of the methods, they have been very, very helpful in my growth as an educator. Now, there was this wonderful kid in my class, Nawaz. I have taken his consent before using his name. Nawaz was an incredibly intelligent and brave child, but he had a problem. He had dyslexia, dysgraphia, and dyscalculia. So he had one of the highest attendance percentages in our school, and he would attend classes. He would go back home. Unfortunately, he would not be able to recall a lot of things. He would be brave enough to face the same ordeal even the next day, and the next day, and the next day. This would continue for months and years, and Nawaz did not give up. I was so proud of him, and one of the things about children with special needs is that they guide you to invent, or they guide you to innovate. I think that's how you work with children with special needs, and they benefit the most out of this practice. So Nawaz had this problem, that very, very clear problem, and this is what I want to share with the teachers, that problems are supposed uh, to be there, for your growth and development. How do you use a problem to come up with a solution is important. What are the things that are there in your favor? What are the things that you need to invent to help students learn to the best of their ability? Now, Nawaz had a problem that he knew tables only up to 5. And that's the case with most children with special needs in my experience. There's no law around this, but usually 1 to 5 is cool, but 6 onwards it's a problem usually. And in a short period of time, I had just started working with Nawaz, and he had his exam 6 weeks later. We would conduct exams every 6 weeks to track the progress. So Nawaz knew tables up to 1 to 5, but not after that. And he knew odd numbers and even numbers because they were easy for him. It was like odd is like leave 1. So it's like 1 is odd, so 2 is not, 3 is odd, so 4 is not, 5 is odd, so 6 is not. Even the same thing, 2 is even, 3 is not, 4 is even, 5 is not. So even and odd. Now, prime number was a great challenge for Nawaz, and I figured out that it was a problem for a lot of children who had been suffering from different challenges. The basic reason was that look at this. I understood their problem. The basic problem was that look at this 20. I'm just putting the odd numbers here. Just look at these. Now, Nawaz said 21 is not a prime, 23 is a prime, 25 is not a prime, 27 is not a prime, 29 is a prime. Now, here 31 is a prime, 33 is not a prime, 35 is not a prime, 37 is a prime, 39 is not a prime. You don't have a, like odd and even, you have a very clear pattern. 1 out, 1 out. That's the way. Prime numbers, that's a little unpredictable. So, based on what Nawaz knew and based on the problem that he was facing, this is what I designed as the prime table. So what you do is, this is what Nawaz and I planned together. You put 2 and put a big bracket here because this is the only even prime number. Now you write all odd numbers. So you write 3, 5, 7, 9, 11, 13, 15, 17. Odd numbers, even numbers, not a problem for Nawaz or most children. All of that, right? Now, since you have put a big bracket after 2, you put a big bracket after 3 and 5 as well. So the next 2 numbers, you have put 2 in a big bracket. After that, the other 2 numbers are also put in another bracket. Now, why has this been done? Because Nawaz knows the table up to 5. That's the second clue as a teacher. So I am trying to invent ways and methods based on what Nawaz knows and what Nawaz is struggling with. And that is what every teacher should be doing in their respective classrooms, innovation. Now, the simple idea is that Nawaz, if the number belongs to the table of 3 and 5, it's not a prime. If it does not, it's a prime. So, 7, can you find it in the table of 3 or 5? No, so 7 is a prime. 9, it's present in 3's table, not a prime. 11, prime. 13, prime. 15, 3's table, 5 table also. 17, prime. 19, prime. 21, 3's table, finished. 23, prime. 25, 5's table, finished. 27, 3's table, finished. 29, prime. 31, prime. Imagine. This was a cakewalk for Nawaz after this. He had absolutely no problem, and I loved how much I had learned about a lot of things, about how children learn, about how do we innovate using what we know and what the children needs help or what the child needs help with. Innovation according to the demand is the concept that I just discussed with you. Working with children with special needs, I had a second idea that helped them a lot. And I think this is applicable to all children, not just children with special needs, but anyone who's struggling, anyone who wants to learn but doesn't know how. I think these methods can be a game changer for them. For example, it was difficult for children with dyslexia, dysgraphia, dyscalculia to identify. This was a very typical question that was being asked those days. So, for example, I'll give you a range of numbers. right? And now what I'll do is I'll ask you to classify if it's proper or improper fraction, right? So this might be easy for a lot of us, but for children with special needs, this was a nightmare. They had a very tough time understanding. I was working with them very closely. They would always get confused how to go about it. So this was one method that we figured out: improper fraction or proper fraction. What exactly is the case? For example, let's understand this. 4 by 5. What was the instruction was that you just use the denominator. Denominator in this case is 5. You put a 5 on 5. That is 1. Right? Now, if the number on top is less than 5, which is 4 in this case, it's a proper fraction. If it's the other way, it's the improper fraction, if it's greater. So now, just look at this. So this becomes proper fraction. Look at 7 by 13. We just pick the denominator. We write 13 and 13. That becomes 1. 7, which is the number on top, belongs to this side of the number line, technically. Or 7 is less than 13, so this becomes a proper fraction again. Moving on, let's look at 5 by 3. What we do is we just choose the denominator. So 3 by 3 is going to give me 1. 5 falls onto the other side, which means this is an improper fraction. And so on. This made their life so much easier, and they were able to crack it very well, understand the concept, and never forget it. Retention is a big problem with students with special needs and with students who are struggling in class in general. So if we devised methods that are very easy to remember, that have a very quick recall value, I think we have already done a great job as teachers. And I think these methods are going to be very specific to your classroom, to your set of students, but making it simpler, making it easier for children to remember helps every single child. And without these basics in place, the children are going to have a very tough time mastering concepts that are of the higher level. So first, let's focus on getting every single basic concept right for every single child in our classrooms, and then use that as a foundation to build on what we want them to learn further. These tricks are specific to your classroom, but then these are very high on retention, and I think they are easier to follow for a lot of students. And that's the beauty of these methods. I was working with Jaimala Didi, who was a non-teaching staff at our school and who had resumed studies after 16 years of break. She was working with me on her grade 10th exam. I had children with special needs who were working with me. I was preparing them for NIOS, and they had a common topic, probability. And there was one very important question, which I think everyone who has learned probability would have gone through at some point in time. That was very high stake for our grade 10th exam, which was this. Just look at it. That's the sample space for 3 dice, for 3 coins being tossed, and that's how you write it. Now, it was very difficult for children with special needs, for adult women resuming studies, to get this pattern right. This is the sample space, and you have NS as 8, and then you use this sample space to figure out the events. So without this, there's absolutely no hope that you're going to get that question right. Simple things how children with special needs learn best, remember even better, and it also helps children who are struggling in regular classrooms and also people who are resuming studies after a while. So just look at the same data. How do we use a technique to help students remember it for a way longer time and make it very simple and easy for them to crack a 5-mark question that's probably going to be there in their board exam. Now look at this. The same sample space can be written as, so if all the 3 get head or all the 3 coins get tails, the first thing is H, 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 T, T, T. You're done with these 2. So the first thing the students write is, if all heads, all tails. Finished. Now, you have head, head, and you change this to tails. Make sense? Now, all you do is, in your second step, you shift this to the middle. You shift this to the middle. So this becomes HTH, and then you shift it to the final end. This becomes THH. And now, my friends, in the third step, all you need to do is, you need to put head in place of tail and tail in place of heads. As simple as that. Which means this becomes HHT becomes TTH. HTH becomes THT, and THH becomes HTT. As simple as that. You're done with the sample space which looked like this a couple of moments back. You don't have to remember much. There's a pattern that you've tracked, and it's very easy for you to crack this kind of exam, this kind of question in the exam without a problem. So these are the techniques that evolves when you work very closely with students, try understanding their problems, and create solutions based on what their challenges are. In conclusion, I would like to say that I had a wonderful time collaborating with Teachmint. Very, very grateful to the organization for the incredible work that it's doing to empower teachers, to help them innovate, to think differently, and I think it's the need of the hour. So, congratulations, Teachmint, on the big win, and I hope that you add more feathers to your cap. Uh, I would want and urge teachers to reflect on ideas that we just discussed. For example, what are some of the chapters? As I have already mentioned, that it could change given your context, given your set of students. So you don't need to follow what I say religiously, but you can definitely draw inspiration from it, adapt it, and implement it in your own classroom settings. So, questions like, what are some of the chapters that you would want to connect together? What are some of the retention areas that you would want to fix with the students? Which means, if there are certain concepts that children often fail to remember, to recollect, how can you ensure that that doesn't happen anymore? In addition to it, things like, how can you innovate and make math and science scare free for children? Not every child is scared of math or science, but most students are. So how as a teacher do you plan to eliminate that fear, eliminate that scare, by tapping into what scares them, and what is that innovation that can help them overcome that scare? So I think, all in all, just work for the children, to empower them, to make their lives easier, to make them fall in love with learning. With that, I just hope that the teachers have gained from this session, and I hope to engage further with all of you through Teachmint. Thank you so much, Teachmint, for this incredible opportunity.